Chapter 4, Section 1. Polynomial functions and models. So, begin with, we have to define the word polynomial. Let's build up to it. A monomial. Mono means what? One, a single. It's a single term. Like x or 3. It's just a single term. Or it could be x to the 27th power. It's just a single term. Next, we have a binomial. Has two terms. Like 3x plus 2. Or negative 5x to the 7th minus 3x. It just has two terms. It could be anything. Typically, monomials are constant terms, constant functions. Binomials are linear equations, like that. A trinomial has three terms. We're used to seeing from the last chapter, quadratic equations. That has three terms. So it's quadratic. Quadrinomial has four terms, or they're called quartic. Or we can call these, since it's three, we'll call these cubic equations. And then so on and so forth. Those are, so basically, the leading part, nomial means the terms. So polynomial, poly means what? Many terms. Polynomials are simply a catch-all phrase we give to all of these and then some. Polynomials are typically written like this. A sub n to the x power n plus a n minus 1 to the power x n minus 1 . That's an example of a polynomial. What would that one be called? This would be called a polynomial of degree n. Why is it called a polynomial of degree n? Because the largest exponent on your variable is called the degree. Actually, everything in this first part here tells us something important. This whole part here is called the leading term. So the leading term is made up of, it's the term with the largest exponent. The term with the largest degree. And degree is the exponent on top of the variable. For example, the reason I say that is, what if I gave you this is my function. What degree polynomial is that? What's the degree of that polynomial? No, the one on the board. This one. Nope. Yes, it's either 27 or 5. Yeah. She waited till you pick this. Because whatever's inside here is the variable in question. Since x, it's 5, so the degree is 5. In mathematics, E is a number. E is called Euler's number. It's like 2.171815. It's a constant. It's called Euler's number. But it's whatever's inside the parenthesis tells us what our variables are, and whatever the power is of that, that's the degree. So the leading term tells us a bunch. It tells us the shape of the curve. It tells us the type of graph we're going to have. And it tells us how many answers we can have. So in the leading term, this part is called the leading coefficient. It's the number in front of x. It's not x, it's the number, whatever's in front of it. If there's nothing in front of it, it's a 1. What does the leading coefficient do? It tells us the shape and direction of the graph. The degree tells us the shape, but not is the same as the leading coefficient. The shape here deals with something we called with the end behavior. Two things can happen with our graphs. Either both ends point the same direction, either up or down, or they point opposite directions. All of our graphs are that way. If you look at the library of functions, it's the same thing. This is called the end behavior. What happens to both ends of the graph? Do they both go up? Do they both go down? Do they go opposite directions? And together, the leading coefficient and the degree tell us what our graph's going to look like. This is called the leading term test. So the degree, we'll look at here. If the degree, remember, where is the degree located? The degree is the exponent of the leading term. So if our n is odd, or if our n is even, that's all we look at for that one. And on the top row, we look at the leading coefficient, the A term. If A is positive or if A is negative. If A is positive and it's odd, the end behavior of our graph will look like this. If our leading coefficient is negative, then our end behavior looks like this. Because it's odd, they point opposite direction. And as if A is positive, then it goes up to the positive. A is negative, it goes down to the negative. If our degree is even and A is positive, that means both ends point the same direction. They point up. If A is negative, they point the same direction and they point down. Now, the reason I put dots in the middle is because depending on the degree, we'll have the degree also tells us the maximum number of solutions possible. Remember, what's another name for solutions? Zeros. What's another name for it? X-intercepts, right. And there are a couple other ones we'll get to later on in the course. So, for example, The reason I say maximum number of solutions possible, because if I give you this equation, what's the basic graph going to look like? Well, what's the leading coefficient and what's the degree? One. The A cannot be X because that's its coefficient, it's number in front of X. So this is greater than 0 and this is even. Let's look over here. Greater than 0 and even, so that's our graph. It's going to look like this. So we know our graph is going to look like this. If it's like this, it only has one solution. If it's like this, it has two solutions. If it's like this, it has 0 solutions. So that's how come I said it's the maximum number of solutions you can have. And likewise, if we had that, A is 1, N is 3. So it's greater than 0, and this is odd. So look at our leading term test. Greater than 0 and odd. So our graph's going to look like this. It could look like this, where you have 1, 2, 3 solutions. Again, that's the N, 3 solutions. Or we can have 2 solutions. Or we can have 1 solution. If the degree is odd, can you have 0 solutions? Why not? Yes, but not the right reason. Because it has to, an odd degree has to cross the x-axis because they point opposite directions. One of those has to hit the x-axis. So you have to have at least one solution with odd degrees. Even degrees, you can miss it altogether. So for example, if I gave you an equation that looks like this, our graph can look like this. 1, 2, 5, 2, 4. Like this. 1, 2, 3, 4, 5 solutions. We can have 4 solutions. Or we can have 3 solutions. That's 5, 4, 3. We can have 2 solutions, but we have to have at least one solution in odd degrees. The degree also tells us something else. We know how many solutions we have, but how many vertices do we have? What's a vertice? What's a vertex? Yeah, it's the highest or lowest point of your graph. Over here, there's our vertex. It's the lowest point in this case. How many do we have? Just one. How many do we have over here? We have one there, and we have one there. We have one there, we have one there. We have two vertices. In this one, we have 1, 2, 3, 4. 2, 3, 4. So if n is 2, then we have one vertex. If n is 3, we have two vertices. If n is 5, we have 4. So what do you see there as the rule for that number of vertices? Yep. The maximum number of vertices is equal to n minus 1. So far, so good. To graph a polynomial, what are all the things that we can find? We can find the x-intercepts, but not just yet. Well, that's the rest of this chapter. We can find the y-intercept. What else can we find? The shape, the direction, direction. There's a couple more we find. We'll add to this list. Remember, our polynomial looks like this. So what does this shape, what does this formula tell you? What does it tell us that we have to look for? Whenever you get an equation, you notice the exponents. They're decreasing in size. Always put your equation, as soon as you get it, check to see the exponents of the x. Make sure they're decreasing in order. And then look at the first and the very last term, the constant term. The constant term tells us what? The y-intercept. That's the y-intercept. The shape and the direction are given to us from where? From the leading term. The x-intercepts, that is going to take us the most time. That's what the rest of this chapter is about. Let me give you some examples here. Let me find some examples here. Over here. So here's the whole process. What we're gonna do in this chapter. So I'm gonna give you a polynomial. So we know that the y-intercept is at -3. We know a is 1, the degree is 2, so we know it's a quadratic equation. We know the shape of it now. The only thing we don't have are the x-intercepts. The way we find the x-intercepts is we have to break this equation down to its smaller pieces, factor it out. So we did that. We have x times x is that. Its second sign is negative, so it tells us the signs are opposites. The bigger number gets the negative. What times what is 3? When we subtract them, we get 2. 3 and 1. So the bigger number is 3, it gets the negative. Then from here, what do? Once we factor them, once we get them down to what are called linear binomial terms, we set them equal to 0. Because we're looking for the x-intercepts. So x is equal to -1 and x equals 3. Those are my x-intercepts. Actually, those are my zeros. Why are they called zeros? Yeah. If I place these numbers back in the equation, it'll equal 0. So let's try it. So we have x squared minus 2x minus 3. Let's try -1. -1 squared, 2 times -1. -1 squared is 1. Negative times negative is positive. 2 times 1. 3 minus 3 is 0. Same thing with the 3. 3 squared, 2 times 3 minus 3. 3 squared is 9. 2 times 3 is 6. 9 minus 9 is 0. You see what happens here? If I plug these back in here, I get zeros. That's how I know these are my x-intercepts. If it doesn't equal 0, then it's not an x-intercept. That's pretty easy. We've been doing this stuff already. How about if we had this equation? What if we had this equation? Our objective is still to put them in the parentheses. But we haven't discussed this yet. Whenever you have 4 terms, it's a cubic equation. We're going to look at a method called grouping. Grouping, what it does is takes the first 2 terms, puts them in parentheses. Takes the next 2 terms and puts them in parentheses. Now factor them. What can we factor? What do these 2 have in common? How many x's? They have 2 x's in common. So if I took away 2 x's there, I just get x. If I took away 2 x's from this one, I just have a 3. What do both of these have in common? If the middle term is a negative, include that in the parenthesis. If it's a positive, you don't have to. So they both have we have to take out the negative, and they both have a 4. So whatever we factor out, we divide by these. So negative and negative makes it a positive. 4's cancel, so we have an x. Negative and negative becomes a positive. 12 divided by 4 is 3. We're almost done. Now we only have 2 terms. What do they both have in common? The x plus 3. Since we took out the x plus 3, whatever's left goes inside the next parenthesis. So those are the coefficients. X squared minus 4. Take both of those, set them equal to 0. So there's our first answer. And set this one, x squared minus 4 equals 0. Solve for x. X squared equals 4. Square root both sides. So x equals plus or minus 2. Whenever you square root something that's squared, you have to put a plus or minus in front of the answer. How many solutions do we have? 1, 2, 3. Yeah, that's how many you're supposed to have. Okay, I'm sorry I kept you all a little late, but we'll pick up from here next time.